This video is just going to include 5 more practice problems for permutations and combinations. So number 5, how many permutations of the letters are there in the word statistics? Remember, we don't want to count the repeated letters. So the first thing we need for our numerator is the number of letters in statistics, and that is 4, 5, 6, 7, 8, 9, 10. So 10 factorial is our numerator. And then how many repeats do we have? The letter T is repeated 3 times, so we're going to divide out 3 factorial. The letter S is repeated 3 times, so we're going to divide out the letter S 3 times, 3 factorial times. And the letter I is repeated twice, so we should divide out 2 factorial times, and I think that gets all of the repeats. So total number of letters, and then each individual letter that's repeated divided out. Okay. How many different ways can 10 different books be arranged on a shelf that can hold 6 books? This is a permutations. 10 permutate 6, 10 factorial divided by 10 minus 6 factorial. So 10 factorial divided by 4 factorial, and then you should go to a calculator for the answer to that one. 7, there are 5 different colored marbles in a bag. Sarah will pick out 3 marbles without looking. How many different combinations can she pick? So we're going to do 5, choose 3. Because once she picks 1 marble, then that is no longer open for consideration, so it cannot be repeated. And ultimately, we don't care the order in which she picks those marbles. So that'll be 5 factorial divided by 3 factorial times 5 minus 3 factorial. And then if you simplify that down, it really starts to look like our repeated letters situation. And then, of course, a calculator to solve. Number 8. In how many ways can 7 children be seated in a row in a school auditorium? There are no restrictions. All we know is that we have 7 kids and we want to order them, so that's going to be 7 factorial. Remember, we got 1, 2, 3, 4, 5, 6, 7 ways we could sit. But as soon as we sit some kid down here, 1 kid's already sitting down. So now we only have 6 possible ways here. And then now that those 2 are sitting, we only have 5 possible kids that we can put in the next seat. So there you go. That's just a straight up factorial fundamental counting principle problem there. And erase that. Number 9 here. How many ways can a 4-digit code be created using 6 digits? So 4-digit code, 1, 2, 3, 4, 6 digits, 2, 3, 4, 6, 7, and 9, if repetition of a number is allowed. So what that means is 2, 3, 2, 6 is a legitimate code. So is 2, 2, 3, 6, and any other combination of those 6 numbers that you could create. So 6 possibilities raised to the power of 4 different digits in the code, and use a calculator to find out the total number of codes that you can create.